Welcome back to our Understanding Alarm Trip series from More Industries. In Part 6, we explored how intrinsically safe systems protect hazardous areas by limiting energy to safe levels. You learned how traditional IS designs require Zener or isolated barriers, and how each has trade-offs in grounding, noise immunity, and cost. We then introduced the SPA 2IS Intrinsically Safe Alarm Trip, which integrates the barrier directly into the alarm trip. This streamlined solution reduces wiring, cabinet space, and installation time, while keeping safety front and center. Now that we've seen how the right alarm trip design can simplify hazardous area installations, let's examine how redundant architectures can enhance reliability. Some processes are too important to trust to a single alarm trip. In these situations, a voting strategy adds layers of safety and ensures high process availability. By using multiple sensors and alarm trips in a structured voting scheme, operators can confirm real issues, filter out false alarms, and maintain operations without unnecessary interruptions. In many critical industrial processes, relying on a single alarm trip strategy may not provide sufficient safety or availability coverage. For example, if a single pressure or temperature sensor were to fail, or if its connection wires were damaged, the layer of protection offered by a single alarm trip would be unavailable until repairs were made. By contrast, incorporating a redundant sensor and alarm trip not only enhances safety coverage, but can also help prevent costly process shutdowns and potential environmental harm. Voting strategies use multiple input sensors, alarms, and/or relays to decide when action should be taken. In a 1 out of 2 voting scheme, either input signal, corresponding alarm, or input fault can initiate a trip in the system. A 2 out of 2 voting scheme requires both units to be in an alarm state, which increases process uptime or availability and reduces the likelihood of spurious trips. A 2 out of 3 voting scheme strikes the best balance, requiring agreement from any 2 alarm trips or systems. This strategy offers very high process availability, safety, and flexibility while also reducing false trips. A real-world example is found in refineries and gas processing plants, where flare stacks handle process upsets and burn off volatile gases. If the flame goes out, it can create safety hazards, environmental issues, and costly shutdowns. To detect flameouts with high confidence, 3 temperature sensors feed 3 alarm trips, wired in a 2 out of 3 scheme, engaging the trip circuit only when 2 sensors detect low temperature. Redundant alarm trip strategies are used anywhere process safety and uptime are critical. In these systems, multiple sensors are often measuring the same process variable and are wired to their own dedicated alarm trip or system. The overall alarm circuit will be tripped when the voting strategy requirements have been met. While these strategies are essential for safety, they also deliver significant operational advantages. By reducing nuisance trips, they help avoid costly unplanned shutdowns and lost production. They improve process uptime and give operators greater confidence in the accuracy of alarm signals. Over time, this reliability lowers maintenance demands, minimizes troubleshooting, and supports smoother, more efficient plant operations. In this video, we explored why critical processes demand more than a single alarm trip, how voting strategies like 2 out of 3 balance safety and availability, and how redundant alarm trips reduce false alarms while maintaining protection. By employing these dynamic alarm architectures, you can improve reliability, avoid costly downtime, and keep your process running safely and smoothly.